Hello, my name is Devin. My YouTube channel is DRG Brothers, and today we're going to be talking about exponents and logarithms again. This is more of a follow-up to the previous videos that I made on exponents and logarithms. This is just some extra information, and I have some new stuff to bring to the table to show you guys today. So, the first thing I wanted to tell you. So, every single number can be written as an exponent with any base. So, for example, let's say I wanted to write, let's do the first couple of numbers. So 2, 3, 4, 5, 6, 7, let's do 8 too, okay? So now, and we're going to do them with 2 base, okay? So 2 base means that it's 2 to the power of something, okay? I know that's a 0, but that's like something there. Alright, so 2, as we should know, is 2 to the first power. I mean, that's pretty simple. We also know that 4 is 2 squared, and we know that 8 is 2 to the third, okay? But what about 3, 5, 6, and 7? Well, they have their own values too. 3 is approximately 2 to the power of 1.585, approximately. 5 is 2 to the power of 2.322. 6 is the power of 2 to the power of 2.585, and lastly 7 is 2 to the power of 2.807. Okay? I'm sorry if it's a little blurry, I'll fix that. Okay, but we can actually use this in calculation. So, I'm pretty sure I covered this in one of my other videos. But if you have 2 things with an exponent and you multiply them together, you add the exponents. So like 1 x to the first power times x to the second power is x cubed, to put it simply. So what we can do is we can actually test this. Now we know that 2 times 4 equals 8, but what if we really wanted to test that? We can test that using this. So, just to keep it simple, we know that we know that we're going to write everything as a power now. So we have 2 to the first power times 2 to the second power. And let's just say we didn't know what 8 was, okay? Let's just say that. We don't know what this is. But we know that 1 plus 2 is 3. So we know that the answer is 2 cubed. And if you look back up here at our little chart, we see that 8 is 2 cubed. 2 cubed. Now, that might be simple enough, but we could go even bigger and do this in a different base. So I'm going to change this to e base. It's now e to the power of something. And e, in case you guys didn't know, is Euler's constant, approximately 2.71828. So it's a little larger than 2, and it's larger than 2 and a little less than 3. So I'm going to change this to e base now. And we're going to do something different. Let's say 3 times 5. We'll do 3 times 5. Okay? And what we can do as well is we can write this as a log as well. So, yeah, we can write this as a log if we really wanted to. So what we can do, here's how we would solve this as a log. We do, let's say, we wanted to find out 2 to the power of what is 8. Okay? Let's say we wanted to do that. We would write that as log base 2, 8. Okay? That's how we write it. And what we can do is we can split this up by the bases. So here's where the e base comes in. So we know we can split this. We'll use e base here, but you could use any base you want. So we're going to do the log base e of 8 divided by the log base e 2. We're splitting it up, okay? And I have a chart in front of me that has all the values, so you guys can't see it though, unfortunately, but yeah, the top one is 2.079, and the bottom is 0.693. But you'll find if you multiply 0.693 times 3, you get 2.079. So the answer is 3. And that checks out, because 2 cubed, as we've already shown above, is 8. Easy peasy. Okay. And we could even use this to find out some stuff we didn't know. Like, I don't know, personally, what pi base is. But what we can do is we can sort of figure that out. So let's say we wanted to find out what 8 was in terms of pi base. So pi to the what power gives us 8. Let's say we wanted to figure that out. We're going to set it up as the same as this one. So the base below is the one that we don't know about. Like 2. It's the 2 base in the previous problem. So what we can do is we can do the log base pi 8. And again, we are going to use e here, but you can use any base you want. Any base at all. It doesn't matter. So we're going to split that up. So it's the log base e of 8 over the log base e of pi. Alright, and that's, so we know that the top is 2.079 approximately. And the bottom, we're going to have to approximate here since pi is a never-ending decimal. Even though we were already approximating before, but that's going to be about 1.1. It's around there. That is a rough estimate. You could get way closer than that. But basically, that means that, yeah, we can use this to figure out what pi base is. Alright, so now we're going to move on to finding the stuff in the equation. So, for instance, if, let's say we wanted to find out the value of x in the equation 5 to the power of x equals 20. How would we figure that out? So the first thing we're going to do is we're going to take the log of both sides. So it's the log of 5 to the x power equals the log of 20. And if you remember from my previous video on logarithms, if there is no base written, it's assumed to be base 10. Okay? So, now what we can do is, because there is a log, we can move this x to the front. So now we can write x log of 5 equals the log of 20. And now we're going to divide each side by the log of 5. And that leaves us with x equals the log of 20 over the log of 5. And you might say, Devin, we have a 20 and a 5. We can divide that. Why is the answer x equals the log of 4? Now, the reason it's not is because, keep in mind, this is a logarithm. We have a base 10 here. This is asking 10, what to the power of 10 equals 20 divided by what the power of 10 is equals 5. That's what it's asking. And just in case you were wondering, and if we were to approximate this, approximately this would be, because this is the furthest we can go. This is an exact answer. If we wanted to get a little more convenient and get a little more in, if we really wanted to do that, we could. We could find that the log of 20 base 10 is 1.3 0.301 divided by 0.699. And I'll let you work that out if you want to. Okay, so that works all in well when we have numbers. But what if we have e, like a variable? So we're going to try the same thing again, but with a slightly different formula. E to the x power equals 5. We're going to try to solve that now. Now, you might think this is the same as the other one, right? All we have to do is put a log in front of each one and bam, follow the same steps and we're done. But it's not that easy. What we have to do is we have to take the natural log because we have e, we have our variable. So we have to take the natural log, written like that, e to the x equals the natural log of 5. Now we're going to divide both. Oh, wait, we have to move the x in front. And then we're going to divide both sides by the natural log of e. And here's a cool fact too. We can write it again as like the x equals the natural log of 5 over the natural log of e. But we can actually go one step further. And no, not by like using the natural log with a base or whatever, no. What we can do here is it turns out the natural log of e is 1. So the answer is just x equals the natural log of 5. Alright. Now we're going to go, I'd say a little bit more sophisticated. Alright, and then we're going to wrap up with this video. Excuse me 1 minute, I didn't grab enough paper. There we go. So, what we're going to try now, I have 2 more problems, and if you want, they're fairly similar to the ones we've already done, so if you want to kind of try to work them out, then you can. So, the first problem is 2 log of 3 base 3x equals the log base 3 of 81. Go ahead and solve that one if you want. And then the other one that we're going to solve is 1/2 the natural log of x equals 2 times the natural log of 3. That's the second one we're going to solve. Now the first one, alright, now here's the first one. So what we're going to do is, first we have to, because here's the thing, we can unapply these logs. But in order to unapply them, there has to be nothing in front of both of them. And there's a 2 here. So remember how in our previous one, where we would use the log to move, like in our previous problem, the e to the x, we would use the natural log to move the x to the front? Well, we're going to reverse that. We're going to move the 2 back, so it's the log base 3 x squared equals the log base 3 of 81. And now we can unapply, or essentially cancel, but the word is unapply, these logs. So we're left with x squared equals 81. But now that we've done that, it's plus or minus. So we're going to take the square root of both sides, the plus or minus, and that's going to be x equals plus or minus 9. But that's not all, because you can't have the log of a negative number. So this up here, this won't work if x is negative 9. So that means the x has to be 9 because of the logarithm rules. Okay? Now we're going to do the other one. Now, we're going to start essentially the same way. We're going to move this 1/2 onto the x. So we have the natural log of x to the 1/2 power, yeah, no, that looks a little weird, equals 2 natural log of 3. And then we have to get this out of the way too. So we're going to square the 3. The natural log of x to the 1/2 power equals the natural log of 3 squared. Okay, now we can drop the logs. We can unapply them. Sorry. And we have x to the minus 1/2 power equals 3 squared. And we know that 3 squared is 9. So now where do we go from here? Well, what we have to do is this 1/2 essentially means that we need to square it. We need to square everything again. So if we square it, that makes x normal now, but now it's 9 squared, so x is equal to 81, and that is our answer. I hope you enjoyed this video. Please tell your friends about this, friends and family. Please subscribe, leave a like, and just thank you. Alright, so thank you very much for watching, and we will see you for another video. Bye, guys.